Hey there. I don't know about you, but I always had trouble remembering the quadratic formula. It seemed like something we just needed to memorize, and I was never good at memorizing. So now I can remember it just because I've taught it so much. But here is I want to show you the derivation of how they came up with it, how they got what it, how they got what that monstrosity is, right? Basically, what do we use the quadratic formula for? We want to find, I have a quadratic here, just the basic standard form quadratic, ax squared plus bx plus c. We want to find what values of x makes that function equal to 0, or in other words, what values of x cause that function to cross the x-axis, the x-intercepts. So we're finding the roots, which are also called the x-intercepts, which are also called the zeros. We're going to find what x values make that 0. But obviously, we're doing two different things with x here. We got x squared and x, and then we've got a constant here without an x, without a variable. So it's not as simple as just getting x by itself necessarily. We have to do something in order to do that. If we know all the numbers, if we know what a, b, and c are, then we can possibly factor it. But if we don't, we have to come up with some kind of formula to put in any values of a, b, and c and have it work. So what they've decided to do years and years ago, decades and centuries ago, whatever it was, they decided to solve this equation in terms of a, b, and c so that you have x equals, and then it's some kind of formula with a, b, and c in it, so that you can put in any values of a, b, and c, and you get a value of x, or two different values of x, or possibly no value of x, that makes this function equal 0 at that value of x. So they decided to solve it by completing the square. I'm going to do a different video at another time of how to complete the square, but I'll go over it briefly while I'm doing this video. First of all, to complete the square, I get rid of my constant. Since it's an equation and I'm going to solve it by completing the square, I move the constant to the other side. So instead of rewriting this, I'm going to subtract c from both sides. I'm still going to leave a space here though. Let's say equals negative c. I just subtracted c from both sides. Well, now I've got this partial quadratic over here. It's actually a quadratic, but I've got this, what could be a trinomial if I had a constant here, because I moved my constant, but I want to get this trinomial. I don't have my third term, but it's going to be a trinomial that is a perfect square binomial. Okay, so remember how, like, let's say x minus 2 quantity squared is the same thing as x minus 2 times x minus 2, right? And if you multiply that all out, you get x squared minus 4x plus 4, because negative 2 times negative 2. And that is a perfect square trinomial. So that's what I'm going to make out of this ax squared plus bx plus something, right? So I'm going to make a new perfect square binomial. And what it's going to do is, in order to do that, first I want to factor out that a, because I want my first term inside the binomial to be x. So I'm going to factor out that a. When I factor out that a, I'm going to do another trinomial up here just to make it real clear. When I factor out that a out of all of these, I'm going to get x squared plus, well, I can't really factor out an a, but I can divide by a. I'm going to get b over a x. All right? Now, this thing inside this parentheses is what I'm going to make my perfect square trinomial. So in order to complete the square, right, I take my middle term and I take half of that, and that's what I know. That's how I know what to put here. In this case, my middle term is b over a. It's kind of weird, but my middle term is b over a. Half of that would be b over 2a. It's basically saying ba times 1/2, or divided by 2, right? So now, what do I put here? Well, just like in my x minus 2 squared, my last term was just this number times itself, or that term times itself. Well, that term times itself, b over 2a quantity squared, is going to be b squared over 2a times 2a, which is 4a squared. All right. Now, now I've increased the value of the left side of my equation. I've increased what's inside the parentheses by a value of b squared over 4a squared, but I've increased the value of that entire side by that times a. Remember, I'm multiplying a by everything in this parentheses to get what's actually on that side of the equation. So that times a is what I have to add to the other side to keep my equation balanced, to get my equation true, right? So I take this, which is, let me write this separately. I have a times b squared over 4a squared, right? Well, that's going to be ab squared over 4a squared. Well, that reduces because there's an a here and an a squared there. It's going to get rid of that a squared on the bottom and get rid of the a in the numerator there. And so this here, right there, is what I have to add to the other side. And I'm going to put that, let's say, I'm going to put that in front because what I've got over there is negative. So I'm going to add b squared over 4a, say that's minus c. So then this I can put as squared. With me. All right. Now, what do I do next? I have to remember the goal. Always remember the goal is to get my x by itself. So I have to work kind of outside in and get rid of all my other stuff. Well, the next thing to do would be, I'm going to rewrite this again, b squared over 4a minus c. Well, the next thing that's preventing, the most outer thing that's preventing my x from being by itself is this a being multiplied by everything. So I got to divide both sides by a. Okay. Now, when I divide both sides by a, I just divide it on the left side and I just get x plus b over 2a quantity squared over there. And I have to divide both of these terms on my right side of my equation also by a, obviously. So I get b squared over now 4a squared again. So that a basically divides back out, or divides again. This is going to be c over a. Doesn't look too familiar just yet. But remember the goal, x by itself. Next thing that's preventing x from being by itself is this pesky squared right there. So I'm going to take the square root of both sides. Square root of both sides. All right. So I'm going to have over here, I'm going to have x plus b over 2a. And that equals, I can't combine these, right? Because they don't have the right, they don't have the same denominator. But if I can make them have the same denominator, notice I can find a common denominator. A common denominator between 4a squared and a would just be 4a squared. So that my b squared over 4a squared already has that denominator. So if I multiply the other fraction here by 4a over 4a, then they have the same denominator, and I can combine them. I'm going to have b squared minus 4ac over, they're each individually over the same denominator, so when I combine them, they're going to be both over 4a squared, and that's all under the radical. So I'm going to write that again. When I write that again, check this out. B squared minus 4ac. That's starting to look a little bit more familiar. 4a squared, all under the radical. Notice when you have two things that are divided or multiplied and they're both under the same radical, you can split them up and give them their own radical. So I can say b squared minus 4ac here under its own radical divided by the square root of 4a squared. Well, now notice 4a squared is a perfect square. So if I take the square root of it, I can write that. This is the same. I can write the bottom now without the radical, because I can just take the square root of what's inside and I get 2a. Okay. But back up a couple steps here. When I take the square root of both sides to get rid of this square, this thing that I end up with on the other side can be either positive or negative, because the negative times the negative is a positive. So if I have something under a square root radical, that thing is going to be either positive or negative. So I'm going to write plus or minus. Very important concept. When you take the square root on your way to solving for an equation where the x is somewhere under a radical on the other side, or somewhere being squared on the other side, sorry, you take the square root, you have to be plus or minus on that then. So now what's left? Okay, well, I've still got x not quite by itself. The only thing that's preventing my x from being by itself now is this plus b over 2a. So I'm gonna subtract that from both sides. Since my radical term here has the plus or minus, I'm gonna keep that at the end of my little term there, though, of that side of the fraction, that side of the equation. So I'm gonna subtract b over 2a from both sides. So I'm gonna be left with just x. And when I subtract that, I'm gonna put that first. I'm gonna say negative b over 2a plus or minus got b squared minus 4ac over 2a. Notice now these fractions over here have the same denominator, so I can put them as one big fraction. I can put them as both numerators added together, negative b plus or minus the square root of b squared minus 4ac all over 2a. And that you'll recognize as the quadratic formula. So all I did, I solved for x by completing the square, but instead of knowing all the values, I just kept in mind how to complete the square. You take half of your middle term, your b term, what becomes your b term when you factor out the a. You take half of that, and that's what's in the parentheses that you're squaring, and then you take that squared and put that there. Therefore, you have to add that to the other side too, and it's just a matter of manipulating that equation to get x by itself, and you end up with a formula that works for any quadratic. Even if that quadratic has no real zeros, meaning if the parabola that quadratic makes does not cross the x-axis, it has no real zeros, but you can still use this to find what they call imaginary zeros, or at least not real zeros. You can get answers even if they're not real answers, and that doesn't mean the quadratic's not real. It just means it doesn't touch the x-axis. So I hope this has been helpful. If you have questions, feel free to ask. And have a great day, and I'll see you later.